Hey Geometry, it's a Sunday afternoon here at the Shellhammer household, so I'm going to try really hard to keep everyone else quiet, but yeah, you may hear some kids bopping in and out as I record. It's okay though, it's life, right? Alright, first of all, the instructions here say write an equation of the line that passes through the origin and intersects 2x plus 5y equals 7 to form a right triangle. Sorry, a right angle. So the origin is pretty simple to figure out. It's at 0, 0. So it's going to pass through the origin and intersect with this line. So go ahead and change this into slope-intercept form. We've talked quite a bit about the slope of one line and then the perpendicular slope of the other. If I multiply them together, the slope of one line times the perpendicular slope, I'll get -1. That my perpendicular slope is the opposite reciprocal of the original slope. Let's fix that. So the opposite reciprocal of m1 is equal to my perpendicular m2. We'll get some numbers in there and hopefully it'll make sense. So I need to change this into slope-intercept form. Y equals mx plus b. So let's subtract 2x from both sides. And I have 5y equals -2x plus 7. Divide everything by 5. And I get y equals -2/5 x plus 7/5. The slope of this line is -2/5. So my perpendicular slope is going to be opposite sign, flip the fraction. So right here is the slope. Now I want an equation of the line that passes through the origin and intersects the line given. So my slope is going to be 5/2, and I need to use the point, the origin. So using the slope-intercept form again, I'm going to plug in what I know. I don't know my y-intercept, but I know x, I know slope, and I know y. Y is 0, slope is 5/2. Oh, sorry, hold on. Y is 0, slope is 5/2, x is 0, and plus b. Well, those cancel out, that's gone. B equals 0 in this case. So my equation is going to be y equals mx plus b. I don't have to write the b though because it's 0. Okay, we have a few more of these to do, so if you got confused on that one, don't fret. We'll do a few more. Next, determine whether the lines given by the equations 2x plus 3y equals 6 and y equals 3/2 x plus 4 are perpendicular. Support your answer. So I need to know if this line and this line are perpendicular. To know if they're perpendicular, I need to find the slopes. And at the end, I'm going to multiply the slope of one equation times the slope of the other equation, and I should get -1 for an answer. If I get -1, then I know that they're perpendicular slopes. So let's go ahead and subtract 2x from both sides. My kids are watching the Minions in the background, so if you hear belly laughing, that is why. They really like the Minions. Okay, there's my first equation. The slope of this one is -2/3. This equation is already in slope-intercept form, so I've got the slope of this line is 3/2. So I can do negative 2/3 times 3/2. Multiply across the top and the bottom. I get negative 6 over, oh, sorry, I already did the multiplication. I hate it when I do that. I skip ahead in my brain. I get negative 1, so yes, they are perpendicular. All right, two lines having the same y-intercept are perpendicular. If the equation of one of these lines is y equals negative 4/5 x plus 6, what is the equation of the second line? Well, they're perpendicular, and both lines have the same y-intercept. So B is 6 for both of them. So one equation is y equals negative 4/5 x plus 6. The other one's going to have a perpendicular. So if the slope for this one, rewind a little bit, slope of it for this one is negative 4/5. The perpendicular slope is going to be positive 5/4. So I can use that, but the same y-intercept. Makes sense? So our slope has changed, but our y-intercept will remain the same. So we've talked a little bit today about slopes of perpendicular lines. If I have line 1 with a slope of m, and line 2 is perpendicular to line 1, that means my slope of line 2 is going to be negative 1 over m. Okay, you flip the fraction and you make it an opposite sign, right? That is why if you multiply the slopes, you get negative m over m, because this will be over 1, which is negative 1. I'm sorry about that. When two lines are parallel, so line 1 and line 2 are perpendicular. Line 1 is perpendicular to line 2. When two lines are parallel, line 3 has slope m. Line 4 is parallel to line 3. It's also m. And I can't do any fun multiplication tricks to prove anything. If m is equal to m, then the lines are parallel. They will have different y-intercepts. Every single time. If they don't have different y-intercepts, then they are the same line. Okay, I'm sure we'll have an example of that. All right, so into example 2. What is the relationship between two coplanar lines that are perpendicular to the same line? This right here just means they are on the same plane. The relationship is if you have a slope of m1 and you're perpendicular, so here you have line 1 has a slope of m1, line 2 has a slope of m2. This just means that m2 is actually equal to the negative opposite reciprocal of m1. Those are equal. Okay. I have line 1 with a slope of m1 and line 2 with a slope of 1 over m1, negative 1 over m1, opposite sign reciprocal. Okay. All right, what we see here is I have this red line. The equation of the line is 3x plus 3, where, 3x plus 3, where my slope is 3 and my y-intercept is 3. Then I've got the blue line, y equals negative 1/3 x plus 1. The slope is the opposite sign and the reciprocal of the red line, and my y-intercept is 1. Then I have a green line. you see, this is y equals 3x minus 1. The slope is 3, and the y-intercept is negative 1. So I have two lines with the exact same slopes. Those are called parallel. Same slope, parallel. Opposite reciprocal slope is perpendicular. Cool? Right, given two lines, L1 and L2, with equal slopes, and a line K that is perpendicular to one of these two parallel lines, what is the relationship between line K and the other line, line 2? So if K is perpendicular to line 1, and line 1 and line 2 have equal slopes, I should not be using yellow, it's very hard to see, I know. So I know line 1 and line 2 have equal slopes. So what does that mean? What does that tell us? They're parallel. Line K is perpendicular to line 1, and therefore perpendicular to line 2 also. If someone tells you two lines are parallel, and one line is perpendicular to one of the lines, it's perpendicular to the other. Cool? That really is what I drew for you in the previous slide. I drew that using Desmos, which is a very cool website that you can just go to desmos.com from your computer, or it's an app that you can download. Either one, it doesn't matter. So the relationship between K and the other line, line 2, is they are parallel because they have the same slope. And the relationship between L1, oh gosh, sorry, these are perpendicular. And these are parallel. Okay, let's try some exercises. Given a point, 3, 6, and a line y equals 2x minus 8, what is the slope of this line? Right there. The slope is 2. What is the slope of any line parallel to this line? Equal slopes, parallel lines. Write an equation of a line through the point and parallel to the line. You can do this many ways. Y minus y1 equals m. X minus x1 is one way. Or you can just pick the point and put it into y equals mx plus b, solve for b, and then write your equation. This is the way I prefer because I really like slope-intercept form, so it doesn't matter. I'll do it both ways this time. So what I'm going to do is grab the slope and the point that we're given and plug it into this equation. That equation right there. And then I'm going to do it again, plugging it into this equation. So y minus y1 is 6. Y minus 6 equals m. X minus a negative 3. We get y minus 6 equals 2x plus 6. I'm going to finish this off in standard form. ax plus by equals c. Continuing it right down here. I get subtract 6 from both sides, negative 12. Subtract y from both sides. Subtract y. 2x minus y. There's our answer in standard form. I can flip it. 2x minus y equals negative 12. That works great. Now let's try slope-intercept form. So I take the same slope and the same point, and I need to solve for b. So 6 equals 2 times negative 3 plus b. 6 equals negative 6 plus b. Add 6 to both sides. b equals 12. And then I have my answer. Put it back into slope-intercept form. except now you leave the variables there, and you, yeah, same answer. You leave the variables there and you just keep it in slope-intercept form. These are equivalent. If you look at them for a second, they work out. Now, part D, that question right there. I'm going to go in purple. What is the slope of any line perpendicular to the given line? Well, if the slope of the line is 2, the perpendicular slope is the opposite sign and flip the fraction. All right, find an equation of a line through 0, 7 and parallel to the line y equals 1/2 x plus 5. So our slope here, what is the slope of any line parallel to the given line? Slope is 1/2 because parallel lines have equal slopes. Write an equation of a line through the point and parallel to the line. Use whichever method you want. Like I said, I really prefer the slope-intercept form. I'm going to grab this point and the slope and do some math. Y is -7, m is 1/2, x is 0, plus b. That cancels out. B is -7. So my answer is y equals 1/2 x minus 7. If a line is perpendicular to this line, will it be perpendicular to this one? I don't know. What's the slope of this one? Let's rearrange a bit and find out. I need to put it in slope-intercept form, so I'm going to subtract x from both sides. I have -2y equals -x plus 14. Divide by -2, and I get y equals positive 1/2 x minus 7. If a line is perpendicular to this line, will it be perpendicular to this one? Well, these two lines are parallel. Since these two lines are parallel, if a line is perpendicular to this one, it's going to be perpendicular to that one. So yes. If a line is perpendicular to one line and these lines are parallel, it's perpendicular to the other. Find an equation of a line through the given point parallel to the line x equals -9. Well, what is x equals -9? 1, 2, 3, 4, 5, 6, 7, 8, 9. That right there is x equals -9. Okay, I go to the point x equals 9 and I draw a vertical line. Now equation that's parallel to that will be going through this point. Somewhere over here. Two lines are vertical, they're parallel because that's part of the definition. So we would have x equals the square root of 3. Now parallel to y equals negative square root of 7. Negative square root of 7 is approximately 2.65. So your line y equals negative the square root of 7 is there. Parallel to that, it's going to go through the point 1/2. That's an awesome line. Y equals 1/2, and they're parallel. Two horizontal lines are parallel because that's part of the definition. What can you conclude about your answer in parts A and B? I can also, like anything x equals a number and x equals another number will always be parallel. Two vertical lines are parallel. Y equals a number and y equals a number will always be parallel because two horizontal lines are always parallel. That means that x equals a number and any y equals a number are always perpendicular because one's horizontal and one's vertical. Find an equation of a line through a given point and parallel to the line. X minus 7y equals square root of 5. All right, I need to figure out the slope of this. So I'm going to subtract x from both sides. And then I need to divide everything by negative 7. Y equals 1/7 x plus square root of 5 over 7. I actually don't, negative 7. I actually don't care anything about that. I did that only to get my slope. Slope is 1/7. Okay, I need parallel. So my slope stays the same. I'm going to plug these 2 points in and find my... Actually, this would probably be a case where you don't want to use the slope-intercept form because those two numbers are irrational. I don't want to do a lot of multiplication and division with irrational numbers. It's just messy. So I think I'm going to leave that in the point slope form. X minus x1. I'm going to plug them in here. So these 2 points get plugged in right here, and the slope gets plugged in right there. Let's try it. Y minus pi equals 1/7 x minus the negative square root of 2. Simplify a little bit. Minus pi equals 1/7 x plus the square root of 2 over 7. I could try to simplify this a little bit more, but yikes. Let's just multiply everything by 7. That'll look a little bit nicer. 7y minus 7 pi, say that 5 times fast, equals x plus the square root of 2. So 7y, oh wait, let's get our x first. X minus 7y, so subtract 7y from both sides, equals negative 7 pi minus the square root of 2. Not much nicer, is it? If I write my variables on the left like we usually do. Same answer, I just flipped it over, right? Really messy. I would probably accept a few different ways to write this as long as you didn't start typing in pi and rounding. Okay, we don't want to do that. Or square root of 2 and rounding. Recall that our search robot is moving along the line y equals 3x minus 600 and wishes to make a right turn at the point 400, 600. Find an equation for the perpendicular line on which the robot is to move. Verify that your line intersects the x-axis at 2,200, 0. So our slope is 3. Our perpendicular slope is negative 1/3. And our point is 400, 600. So y equals mx plus b. Let's figure out what that y-intercept is. I have x and y. 600 equals negative 1/3. 400 plus b. 600 equals negative 133 and 1/3 plus b. If I subtract 133 and 1/3 from both sides, I'm going to add 133 and 1/3 to both sides. Sorry. I get 733 and 1/3 equals b. So my equation is y equals m x plus b. Now to verify that it intersects the x-axis at 2,200, 0, all I need to do is plug that into this equation. X comma y. So y is 0, x is 2,200 plus 733 1/3. What is 1/3 of 2,200? I'm doing a little typing in my calculator. Ooh, this is negative 733 1/3 plus 733 1/3. So 0 equals 0, so yes. I did verify it by showing my work, and this line does intersect the x-axis at that ordered pair. So life is grand. A robot, always moving at a constant speed of 2 units per second, starts at position 2550 on the coordinate plane and heads southeast in a direction along this line. After 15 seconds, it turns clockwise 90 degrees and travels in a straight line in this new direction. What are the coordinates of the point at which the robot made the turn? What might be a relatively straightforward way of determining this point? Well, I've highlighted all the important information. I'm going to get some graph paper out and see if I can help myself a little bit in this problem. Okay. I think I can do this without graph paper. This is the 3, 4, 5 triangle that I'm going to mess with, so it's not too bad. Okay, so I'm going to go by tens. My starting point is over 20 up 50. We're doing a speed of 2 units per second. After 15 seconds, that would be 30 units traveled altogether. Right? Because 2 times 15 is 30. We're doing a clockwise 90 degrees, so we traveled that way. What is our slope of this line? I have 3x plus 4y equals 260. I'm going to subtract 3x from both sides. 4y equals negative 3x plus 260. Divide everything by 4. Y equals negative 3/4 x plus 65. I don't really care much about the 65. I know that my slope is negative 3/4. So if I look, let's see, that means I'm traveling in this general direction. I'm not going to write that line yet, though. I just don't want to mislead myself. But if I look, I'm traveling in this direction. I'm going down 3 and over 4. It's a 3, 4, 5 triangle. And I know that because I can use the Pythagorean Theorem. 3 squared plus 4 squared equals 5 squared. Okay, 9 plus 16 equals 25. So I can actually use that here to find out where I end up. Sorry, let's do this. I know I'm traveling 30 units. My hypotenuse of my 3, 4, 5 triangle is 5. 5 times 6 is 30. So I know I need to do that down 3 over 4 6 times to get to my final location, right? Down 3 over 4. So if I start with 20 comma 50, and in my x direction I'm adding 4 6 times, so that's 24. I get 44. And I'm subtracting in the y direction 3 6 times, which would be 18. 50 minus 18 is 32. Yeah, so that is where I am ending up. So I'm going to travel 44 in the y direction, no, 44 in the x direction, and 32 in the y direction. So let's see, this is 10, 20, 30, 40, 50, right about there, and then up 32, 1, 2, 3. So I'm going to erase this. See, I knew I didn't want to draw that line because it was misleading. That right there is where I'm going to turn 44, 32. And I'm going clockwise, so in this direction. And my perpendicular slope is positive 4/3. So I'm going through the point 44, 32 with a slope of 4/3. Let's throw it into the equation, the slope-intercept form. Y equals mx plus b. 32 equals 4/3 times 44 plus b. 4/3 times 44 gives me a fraction, of course. I have 58 2/3. Subtract that from both sides. 32 minus 58 2/3 is negative 26 2/3. So my equation is y equals 4/3 x minus 26 2/3. Cool? Cool. Alright, so if after turning the robot travels for 20 seconds along this line and then stops, how far will it be from its starting point? So, 20 seconds times 2 units per second is 40 units. I've redrawn some of the stuff from the previous page. I found a mistake too. 30 units. And this will be 40 units. And that is garbage. All right, so let's talk through what I just redrew. We started at 2050, we traveled for 30 units, 15 seconds, and we stopped. We made a 90-degree turn and we traveled in this direction. The equation for this line is on the previous slide, and we traveled for 20 seconds, which is 40 units. So we can figure out what our ending point is just by using the slope. So again, I have a 3, 4, 5 triangle. Here's my horizontal. And here I'm going down 40 left, down 4 left 3. So down and left is negative, negative, which is a positive slope. 3, 4, 5 triangle. If I take 5 and I multiply it by 8, I get 40. So 3 times 8 is 24, and 4 times 8 is 32. So I'm going to take my stopping point, which was 44, 32, subtract the x direction, which is 24. I get 20, and subtract the y direction, which is 32, and I get 0. So my new stopping point is 20, 0. What is the equation of the line the robot needs to travel along in order to now return to its starting position? So if you look, we started at 2050, traveled for 30 units or 15 seconds, ended at 44, 32. Turned, traveled for 20 seconds or 40 units, and ended at 20, 0. Now we're trying to get back to the starting position. Luckily, we are a straight line at x equals 20. If we travel that directly north, we will get back to the starting position. Now, how long did it take to get there? We traveled along the line y equals 20. How far did we travel? We traveled along the line x equals 20. We traveled from y equals 0 all the way to y equals 50. And we're traveling 2 units per second. 50 units. 50 units at 2 units per second would be 25 seconds it would take to get back to that beginning spot. Cool? Phew, that was more work than I thought. And that was it. I had one more slide. I didn't know it was blank. Awesome. We'll see you tomorrow.